Now it's the moment you've all been waiting for. What we're going to do today is to start to derive circular functions. And what we've done previous to this is really a review of the Year 11 course. So we're going to really put the foot down now and have a look at a few new things for this year. So let's start with f of x equals sine x, which is this solid lined graph here. And what I've got the graphing program to do is produce the graph of f dash x. And if you have a look at it, it looks very much like the graph of cosine. And what we're going to say is if you think that f dash x looks a lot like cosine, you're right. And what we're going to include is if f of x is sine of x, then f dash x equals the cosine of x. Okay, so the derivative of sine x is cosine x. And it really is as simple as that. What if f of x has some sort of dilation by a factor of 1 on k from the y-axis? Well, what we'll do is we'll use the chain rule to show that if f of x is this, then f dash x will be pulling the k out the front. Okay, and I'll show you how that works. So here is, why aren't you writing? Let's try again. Okay, just had to unpause that and restart it. So let's try this out. So if f of x equals sine of kx, what we've got is a function inside an outer function. So we're going to say that u equals kx and y equals the sine of u. Okay, now let's do du dx, which is k in this case, and dy du. Now what is the derivative of sine of u or sine of x? It's just cosine x, so we're going to say cosine of u. Alright, so now the time to get the derivative, f dash x equals, so remember the chain rule is this multiplied by this complete with the u sub, so that's k times the cosine of u, which is kx. Alright, so there it is via the chain rule. It's on your formula sheet as well, so you don't need to kind of memorize this process, you just look it up. So if you're differentiating sine of ax, then the derivative will be a cosine ax. What about cosine? Well, if you look at cosine here, and then you look at the first derivative, which is the dotted or dashed line there, what you'll notice is that looks very much like sine inverted. Okay, and that's what we're going to conclude. So if you think that f dash x looks a lot like negative sine of x, then you're right. So if f of x is cosine x, then we're going to conclude that the derivative is negative sine of x. What if we've got a dilation? I'll quickly show you how the chain rule works on that as well. So we're going to say that if f of x is cosine of kx, what we'll do is u sub the kx, that's the inside function, y is cosine of u, the outside function, du dx is k, and dv dx, well, or no, not dv dx, dy dx, dy du, oh my goodness, dy du is equal to, now what's the derivative of cosine? We just found out it's negative sine of u in this case. Alright, that by that with the u sub means f dash x must be negative k, so k multiplied by negative 1, sine of u, which is kx. Alright, and here it is on your formula sheet. Alright, now tan again is a little bit different as we've come to expect. So if f of x is equal to the tan of x, then let's have a look at the first derivative. So here we've got tan of x, and we've got the first derivative being this repetitive parabolic looking function that just repeats itself over and over again. Now that function's got a name, and it's called the secant of x all squared. Okay, so what we're going to do is assume that if f of x is the tan of x, then f dash x is going to be 1 over, it's the reciprocal of cosine of x all squared. Okay, now that can be shown to be equal to this thing here, but I generally leave it with the cosine in, so I don't go from here to rewrite it as sec of x all squared. All right. Now, why is it this? Well, unfortunately, I'll just say this. Trust me, this is the case. All right. So it's not a great thing to do, but if you basically look at the graph of 1 over cosine of x all squared, it produces this derivative function here. Okay, and that's why that is equal to that. So the chain rule will again show that this is the case. So if f of x is tan of kx, that is, it's got some sort of dilation factor, then f dash x will be k over cosine of kx all squared. All right. So we just assume this is the case. And again, on your formula sheet, this is written as this. Generally, I use this version of it rather than this. All right, so let's do it. So we're going to go y equals the sine of 2x. So what I'm going to do is I can do this via the chain rule, or I can do this just to assume that this 2 just goes out the front. So I'm going to do it with the chain rule. So I'm going to go u equals 2x, y equals sine of u. All right, du dx is 2, dy du is equal to, now the derivative of sine is just cos, so cosine of u, that multiplied by that with the u sub, that means dy dx equals 2 cosine 2x. Okay, so there it is with the chain rule, but you should be comfortable just using formula sheet. Okay, this is an interesting one, so I prefer to write this like this, sine of 2x all squared. All right, and what we've got here is an inside function. So the sine of 2x becomes the inside function, and the outside function is whatever it is squared. So we'll go u is the inside function, which is the sine of 2x. The outside function is y equals u squared. Okay, let's do du dx is, so we just found out this derivative over here, sine of 2x, that's this one here, is 2 cosine 2x, and dy du is 2u. Alright, so that multiplied by that, so we're going to say that dy dx is 2 times 2, which is 4, u is sine of 2x, and then it's this thing here. So that with the u sub in it, multiplied by this, so cosine 2x. All right, I think there's an identity that is in play when you multiply sine by cosine, but we're just going to leave our derivative as this. All right, couple more derivatives. So we're going to approach this one in exactly the same way, which is y equals the sine of 2x plus 1 all squared. Okay, so our inside function u is the sine of 2x plus 1. The outside function is y equals u squared. All right, what's the derivative of this one here? Okay, so this is interesting. So what I'm going to do is just over here do my derivative. So I'm going to do chain rule to do this one. So this is like the chain in the chain. Okay, so I'm going to go, what if my function is y equals sine of 2x plus 1? So y equals the sine of u, where u is equal to 2x plus 1. du dx is 2, and dy du is cosine of u. They multiply together, so it's going to be dy dx equals 2 cosine, and u is 2x plus 1. So there's our derivative. Okay, so dy d, where am I going to write this? So what I'm going to do is write du dx here, which is 2 cosine 2x plus 1. That's what I just found out there. And that other one's easy enough. dy du is 2u. Alright, so that multiplied by that with the u sub means that dy dx is going to be 4. The u is sine of 2x plus 1. That's this one here. Multiplied by this thing here, the cosine of 2x plus 1. Alrighty. Okay, let's do this one. So rewrite it in a form that I like better. 4x plus 1 all cubed. So u, the inside function, is cosine of 4x plus 1. Y is equal to u cubed. Okay, so du dx. Now see if you can see or think what this derivative is going to be. So the derivative of cosine is negative sine. This 4 will float out the front just like it did with this one here when we derived sine of 2x plus 1. So this is going to be negative 4 sine of 4x plus 1. And if you really want, just do this with the chain rule. So run the chain rule over here in your notes and you'll find that that's the answer there. Okay, dy du is equal to 3u squared. Alright, so it's that multiplied by that with the u sub. Dy dx equals, that's negative 12. U is this, so it's going to be cosine 4x plus 1 all squared. Then just go sine of 4x plus 1. Pretty nice looking derivative. Okay, couple more. Find the derivative of the following with respect to theta. Okay, so just a reminder about tan. If f of x equals tan of x, then f dash x will be 1 over cosine of x all squared. All right. So this one here is the tan of 3x. So what we're going to say is that this 3 here, as per the formula sheet, will go in the numerator. So we'll go dy dx equals 3 over cosine of 3 theta. Yeah. Now that shouldn't be dy dx, it should be dy to theta. So I'll grab my rubber and write that as theta. So dy d theta, okay, is this one here. Okay, this is an interesting one. How are we going to do this? So I'm going to just check this one out using the chain rule. So I'm going to go u equals 3 theta squared plus 1, where y is the tan of u. Okay, so let's do du dx. That is 6 theta. So 2 3s are 6, power goes down by 1, and dy du is 1 over cosine of u all squared. So it's this by this with the u sub. So dy d theta is going to be 6 theta in the numerator, so that times that, over cosine of 3 theta squared plus 1 all squared. All right, so there is your questions for the chain. Let's roll straight on to product rule. All right, so find the derivative of the following with respect to x. Okay, so remember the product rule is one function multiplied by another function. So we write down u, in this case is cosine 4x, and v is the sine of 2x. Du dx is, so this 4 goes out the front, and because it's cosine, that swaps to negative sine, or derives to negative sine. So we're going to write negative 4 sine of 4x. Again, kind of using the formula sheet now rather than the chain rule. Okay, this one, dv dx is 2 cosine 2x. Again, just use the formula sheet if you're not comfortable. I can remember this one, but yeah, if you're not comfortable, yeah, use the formula sheet. So what we're going to do is it's going to be u, so we're going to say dy dx is u dv dx, so it's 2 cosine 2x cosine 4x, so u dv dx plus v du dx, right? So it's going to be this times this. So that's negative 4, so I was a bit preemptive with the plus there because in this case it's going to be minus. So take away 4 sine 4x sine 2x. Now there's probably some trig identities that will shrink this down, but this is absolutely fine for us in maths methods, so we could just slam in, say, pi on 3 for the derivative, and that will evaluate or get us the gradient at whatever point we want. So this will work absolutely fine for us. All right, so only one example for the product rule, and there's your questions. And finally, the quotient rule. So remember, we use the quotient rule when we have one function divided by another function. So we'll go, let y equal 2 sine 2x over x plus 2. So our u has to be the numerator with the quotient rule, 2 sine 2x, and v is the linear x plus 2. Okay, du dx. So we've got 2 sine 2x. Watch the handwriting. Okay, so 2 is going to float out the front. There's a 2 already there, which means it'll be 2 times 2, which is 4. Sine swaps to cosine 2x. So again, just using the formula sheet there. dv dx is 1. So remember that the quotient rule is v du dx, take away u dv dx over v squared. All right, so let's write it out. dy dx equals, so it's v du dx, so we're going to go this times this, which is going to be 4x plus 2 cosine 2x. So v du dx, take away u dv dx, 1 times that, 2 sine 2x, all over v squared, which is x plus 2 all squared, and it's perfectly fine to leave your answer like that. All right, if f of x is this, find f dash pi on 2. This is a really standard exam 1, question 1 problem. So we've got quotient rule, u is x, v is the sine of x, du dx is 1, dv dx is cosine of x. Okay, so f dash x is going to be v du dx, so that's the sine of x, take away u dv dx, x cosine x, that by that, all over v squared, which is the sine of x all squared. Okay, so that's the first part, which is the derivative. Now we've got to do f dash, what was it? Pi on 2. So it's the sine of pi on 2, take away pi on 2 times the cosine of pi on 2 over the sine of pi on 2 all squared. Okay, now the sine of pi on 2. So we're at pi on 2, we're looking at the y value there, which is 1. Take away. Pi on 2 multiplied by, so that is cosine at pi on 2. So this is cosine of pi on 2, which is 0. So that part of it is obviously going to be 0 over the sine of pi on 2, which is 1 all squared, which is 1. So this is going to be 1 take away 0 over 1. That's 1 over 1. which is 1. All right, so it looks really hard, like you'd be like, oh, what's this going to be? I've got to put pi on 2 into this, but they always come out pretty simple like this, and it's really easy if you know your exact values. All right, so there is 9k questions. Again, that sounds like a lot of work there, but it really is rule application, and just remembering that the derivative of sine is cosine and the derivative of cosine is negative sine. So apply that and you can't go wrong. Good luck with it, guys.